So we talked about this yesterday. We already know what the first fundamental theorem of calculus is. We know that when we integrate the function f of x, that is going to give you the antiderivative. And then we're going to plug in the top number minus plugging in the bottom number. And that is the first FTC. That is how we evaluate a definite integral. For these problems, I think it's going to be easier to think about it as integrating a derivative. So like when I say what's the integral of f prime, I know the integral of f prime is just going to give you the original function f, again, plugging in the top number minus plugging in the bottom number. So that's what we knew before this unit started. And then how we kind of expanded that formula is we have the rewritten first FTC, where we basically isolated the f of b. Isolating f of b, you're moving that f of a to the other side. And so we have this f of a plus the integral from a to b of f prime of x dx. And that is one of the common formulas we're going to be using a lot in this unit and for these problems. Since we will be doing word problems, I do find it beneficial to kind of convert those formulas from like their math notation into like more of a verbal notation. So for example, when I say let's integrate f prime of x, we know that f prime of x is really a derivative, and we know that a derivative is basically representing a rate. So if I want to convert that statement verbally, I might just say let's integrate from a to b a rate of change. Well, what's happening when we integrate a rate of change? When we integrate a rate of change, that is going to be basically becoming an amount. So we can already see that's equal to f of b minus f of a. What would f of b minus f of a represent in words? I'm going to describe that as the net change of the amount from a to b. And you might ask the amount of what, and that really depends on the word problem that we're looking at. It could be like the amount of water leaking into a tank, the amount of bananas being put on a shelf, the amount of people getting in line to ride a roller coaster, like the amount of anything that we're going to be looking at. And then same thing for that rewritten first FTC, we can convert that verbally as well. So f of b is often like the end value, or basically what you're trying to find. F of a is basically an initial condition. And what am I adding to that? We're adding to that the integral from a to b of f prime. How are we describing the integral from a to b of f prime? Again, that is just going to be the net change in the amount that we wrote before. And so we're going to use those formulas and then just other like problem solving techniques to answer a bunch of problems today. The way I have the notes set up is we're just going to look at a single problem situation, and then I have like 9 kind of like just follow-up questions of different ways that we can kind of look at it and analyze it, compare and contrast different examples. But today we're not really going to be solving anything. I just want us to practice like setting up the problem. So let's introduce the problem I want to look at today. I tried to pick one that I think most people can at least like somewhat visualize in their head. So we're going to deal with example. We have a capsized tanker is leaking oil into the lake. And so these problems, no matter what we're going to be talking about, they will always follow a similar format. There always is going to be something talking about something flowing into something or entering or something like that, the rate in. And then you're always going to have something talking about the rate flowing out. So maybe you have, I'm trying to think of some examples from other years. You have like fish swimming in a lake, fish swimming out of a lake. You have people in a store stocking the shelves, customers buying things off the shelf, or people getting in line to get on a roller coaster, and then people getting all out of line onto the ride. So anything where there's like this kind of input action and output action. Things I always kind of notice about these problems, I always kind of look at the functions they give us, what they represent, and then the units. Again, we can rely on the units a lot to kind of help us solve these problems. So I'm going to let L of t represent a rate. What is L of being a rate of? It is in gallons per hour. What is L of t representing? It's representing the rate that oil is leaking into the lake. So we have this oil, it is leaking by this function L. Second line, we have 4,000 gallons of oil. So there's a unit of measurement. spilled into the lake at 5 a.m. or T is equal to 5. What is that bit of information telling us? F of A, that's the initial condition. And then we have another function. So this is a function C of T. It is also representing a rate. So it is measured in gallons per hour at which oil is being removed or cleaned up. Do notice that that function doesn't start until T is equal to 5, or basically 5 a.m. Now, if you notice, like I just used the function notation L of T. Normally this was a question, so like as we build on our skills, that will be some actual function, like it might say like L of T is equal to, I don't know, like 200 cosine of T squared over 18, like some weird kind of crazy function. And the function is always going to be given to you in 3 different ways. Your function can be given as an equation. If it's an equation, then it's probably one that's on the calculator for it, so you can just like punch it into your calculator, hit enter. Sometimes they give it to you as a graph. And then sometimes they give it to you as a table of values. Again, to kind of make today a little bit easier as we're building our skills, I took away all that extra information and we're just going to focus on setting up the problem. So I'm just going to go question by question. Definitely stop me and ask questions as you have them. And we'll see how it goes. But I don't want to overcomplicate the formulas, so I will kind of explain my thinking and reasoning as we kind of approach each question. So question 1, it says to write an expression, which may or may not include integrals, to represent the amount of oil that leaks into the lake from 6 a.m. to 11 a.m. So when I do a problem like this, there's several things I kind of look at. I first look at what the question is kind of asking me to find. This question is asking me to find the amount of oil. So to help me kind of form my answer, I kind of think to myself, well, what would be the units if you're trying to find the amount of oil? And so I'll ask you, what units would you use to measure the amount of oil? Gallons. And so then you look at the question and how it's provided. The question is provided in gallons per hour. So similar to what we did yesterday, what operation in calculus would you have to do to convert gallons per hour into gallons? Integral. You would have to do the integral. There'll be some integral, so I'm just going to go ahead and slap down an integral. I know it has to be there, and then kind of fill in everything around it. I see in this problem that we have 6 a.m. to 11 a.m. Where do you think those numbers are going to go? On the integral sign, right? So we're integrating from 6 to 11. I will say for these problems, often we're going to put time on the integral sign because time is going to be like our independent variable. Which function are we going to be integrating? L of T. So we're talking about how much oil has leaked. So we are integrating L of T. It is an integral, so make sure we put dt at the end of that. And then you want to ask yourself, do I need to worry about the initial condition? So this question does say how much oil has leaked into the lake from 6 a.m. to 11 a.m. So in this problem, are we going to be concerned about that initial condition in its setup? No. So again, this one does not have the initial condition because we just want to know how much is leaked starting at 6 and then ending at 11. If this was a question on the AP exam or your homework or your quiz or your test, you would know what that function L of T is, and you would just type that in your calculator, hit enter, and then write down the number. So we're just going to focus on the setup today, and that would be your final answer. Questions on that? I don't want to say the time will always be chronological. Typically, yes, but I'm not going to say always because I can think of times where you would go back in time. Let's try number 2. And again, stop me whenever you have questions. I try to choose like a variety of questions just to get us thinking about how to kind of form these problems. Same situation. We want to write an expression now to represent the rate of change in the amount of oil at 8 a.m. So again, when I approach a problem like this, I look at what the question is ultimately asking me to find. I want to represent something that is a rate of change. In the context of this problem, what is the unit of measurement for a rate of change? Gallons per hour. So I want my answer to be something in gallons per hour. But what is the question already written as? It's already written in the form of gallons per hour. So do I need to do anything like take the integral or take the derivative? No. And that's why I often look at the units. People so badly, like I'm in a calculus class, I need to take an integral or I need to take the derivative, but sometimes you can just use the function as written. So let's think about how we can kind of form an expression. Let's write an expression to represent the rate of change in the amount of oil at 8 a.m. Any ideas or guesses of what this might look like, Sarah?
You do like the derivative of LT, not
So,
derivative, integral of LT, like of 8.
So we're just going to do L of 8. So L itself is already representing a rate. L is itself kind of in gallons per hour. So L of 8, think to yourself, what does that represent? That would represent the rate oil is leaking at 8. Well, what's also happening at 8, as oil is leaking, it's also being cleaned up. So how can I represent how much is being removed as a rate? The rate that's being cleaned up will be minus C of 8. To kind of simplify this and put this into words, because we will see this set up a lot, this is basically the rate in minus the rate out. Again, we'll see these problem situations change, but what won't change is there is going to be some sort of like input and then some sort of output in the scenario. Questions on how I did that one? All right, number 3, same situation. Suppose we know that the amount of oil in the lake is decreasing at noon. We want to write an equation or inequality to describe what we know about the relationship between L of T and C of T at this moment. So we're going to see a lot of problems where sometimes there can be more than one right way to write the problem. This one I can think of probably like 3 different ways you could write it that would all be correct. There's one way that is like very like calculus based, but then other ways which are just kind of pretty logical if you think about it. So first thing I kind of notice is we are talking about at noon. Well, what T value would be associated with noon? That would be T is equal to 12. So if I want to know what's happening at 12, we do want to kind of first think about what we're comparing. Are we technically going to be comparing rates, or are we technically going to be comparing amounts for this problem?
Amounts.
Rates. And what's the clue? Like we do see this phrase amount here, so it looks like we're comparing amounts, but we're really trying to figure out when that oil is decreasing. That's like a verb. What is the oil doing? So we really are going to be comparing rates. So like the non-calculus way of doing this one, I think is the more obvious one. So I have the rate that oil is leaking at 8, not 8, let me try that again, at 12. The rate the oil is leaking at 12, the rate the oil is being cleaned up at 12. If the amount of oil is decreasing, which one of those is going to be happening faster, the leaking or the cleaning up? Which one is happening fast? Which one's going to be the bigger one? The cleaning up, right? So leaking is the slower one, cleanup will be happening faster. Could have also written that backwards. C of 12 would have to be greater than L of 12. Personally, I would probably write it that way. Another way that you could have done it is going back to kind of like calculus. What would it mean if a function was decreasing? If a function is decreasing, we know that its derivative is less than 0. Well, a derivative is kind of like a rate. So like when I say the oil is decreasing, we're basically trying to show that the overall rate is less than 0. What would be the overall rate? That would be L of 12. There's the rate oil is leaking in minus the rate the oil is being cleaned up, and that would need to be less than 0. And you can see how that blue one is basically equivalent to that red one. But if you wrote down any of those 3, that would be correct. Questions on that?
So I just did C of 12 minus L of 2 without the
You said C of 12 minus L of 12?
Yeah, so I was thinking more of just like
How
how like the cleaning up is faster.
That could be fine as long as your inequality worked out the same way. As long as it worked out that C was the bigger one, then it would be fine. So that could also work. Let's try number 4 through 6. Back to like some more like calculus type problems. Same problem situation. An example 4 is I want us to write an expression to represent the amount of oil. So again, we're going to want an expression that represents an amount this time that has spilled out of the tanker and into the lake by 10 a.m. So again, if I'm setting up my problem for this one, if I want to write an expression representing an amount, then I know that that amount is going to be measured in gallons. This problem is given to me in gallons per hour. In calculus, how would I convert gallons per hour into gallons? We would need to integrate, so I know there's going to be an integral sign somewhere, so let me slap it down. I want to talk about how much oil has leaked out, has spilled out, so which function am I going to be integrating? L of t. Don't forget the dt. And then I want to see how much is leaked out by 10 a.m. Where's that 10 going to go? On the top of your integral, so up until 10. And then we still have a few more things to kind of fill in. What else do we need to kind of fill in to answer this question completely? The bottom. What number is going to go on the bottom? 5 is. Where's that 5 coming from? The initial condition. Do we need to worry about adding that 4,000 in this one? I want you to like look at it, and if I kind of phrase it, let's kind of compare them. So this one is similarly worded to that first one. This first one we did not use the initial condition, and it simply stated, find the amount of oil that leaks into the lake from 6 to 11. So basically starting at 6, ending at 11. This one we're on right now, we want to know just like the total amount that has leaked out by 10 a.m. So what do we need to include that initial condition? Yes, what was that initial condition? 4,000, and that 4,000 occurred when t was equal to 5. That is where I sometimes see mistakes, or students confuse like when they use the initial condition and when they would not. So again, just kind of showing when we don't need it. We don't need the initial condition when you're talking about an interval with a clear starting point and a clear ending point from 6 to 11. We need the initial condition if I'm talking about just like ultimately how much is happening by a certain value. Questions on that one?
So that's just basically like the FTC, but.
Yes, that is the rewritten first FTC. And again, if this was a problem on your homework or on an AP exam, you would know LT, punch your calculator, hit enter, and then you would have the answer. Go ahead and try 5 and 6 on your own before I kind of give it to you. They're very similar to number 4, so you can kind of use 4 to kind of model your answer. But I want you to write an expression in number 5, the amount of oil that has been cleaned from the lake by 10 a.m. And then looking at 6, write an expression to represent the amount of oil in the lake at 10 a.m. So the total amount just sitting in the lake at 10 a.m. So I'll give you a few minutes to try those. Again, we don't really have the functions, so we can't evaluate it. I'm mainly just focusing on the setup for today. Anyone feel brave want to share the answer they have for 5? Go ahead, Mitch.
That is 4,000 plus integral
Mm-hmm.
From 5 to 10
Mm-hmm.
CT dt.
So you put 4,000 plus in front of that one, and I didn't write 4,000 because there's not 4,000 plus in this one. What is the initial condition? How much has been cleaned at t is equal to 5? 0. So technically the initial condition for the C function is 0. Like if you left off the 0 plus, then that's fine. And again, that's coming back to the problem. That 4,000 is going with how much has been spilled into the lake when cleanup beginning. So there hasn't been anything cleaned up until 5. So technically your initial condition for the C function would be 0. So that's what I should have for this one. 6 then, I'm just going to kind of combine my answers I have for 4 and 5. We want to write an expression which may or may not include integrals to represent the amount of oil that's in the lake at 10. So again, if I want the total amount of oil in the lake, we know there is 4,000 gallons at some point. When was there 4,000? That was when t was equal to 5. And then up until 10, that would give you the amount of oil that has leaked into the lake. Minus, so no cleanup has started, starting at 5 and then ending at 10, that would be how much has been cleaned from the lake. Again, if you need to evaluate that, when we have a function, then you can just type that into the calculator. I would probably condense this. So since both of these are integrals that are going from 5 to 10, you can write it as a single integral, and that just makes it look a little bit cleaner. So I have that 4,000 plus the integral from 5 to 10 of L of t minus C of t dt. But of course, either of those answers would be fine. Yes, Ramani?
For part 5, didn't you do like 4,000 minus the integral?
So I didn't even touch that 4,000 because number 5 is only asking me how much has been cleaned. So if I'm just talking about the total that has been cleaned, 4,000 would be how much has been leaking. So it's not even attached to that cleaning function. So 0 has been cleaned. And then how much have you cleaned? You cleaned from 5 to 10 of the rate. I did end up subtracting it when I wrote it completely because we want to think about, we have like the amount in minus the amount going out. Any other questions on either of those three? All right. Number 7. Wrote this question because it's a common question we see on the AP exam. Definitely have one like this on your quiz next week. But I have write an equation. So again, if we see write the equation, we know there better be an equal sign somewhere in the expression that you write, which may or may not include integrals. That when solved for x would tell us when the lake would be free of oil. We're not going to have to solve this one, and oftentimes you don't have to solve it, you just have to set it up. But we do want to write an equation that if you were to solve it, then that x would represent when there's no more oil left in the tank. I like kind of doing the easier parts first when I'm kind of writing and setting up these problems. If I'm saying that this lake is free of oil, what is that telling you about your equation? How much oil will be left if it's free of oil?
0.
0. So what's my equation going to be equal to?
0.
0. So I at least know that that is going to be in my equation. I want to show when the amount of oil is equal to 0. And then it's going to look a lot like number 6. So how much oil do we start off with? We started off with 4,000 gallons. And then what happened? Well, starting from 5 to some number, do we know what time we're stopping at?
No.
No, so that's where the x is going to go. So from 5 to something, if I integrate the rate that it's leaking minus the rate that's being cleaned up, that would be basically the amount of oil. And then we want to show that that would be equal to 0. And of course, I could write that as 2 separate integrals. Where your points will be coming from, of course, on this one is having the initial condition. X is referring to a time, so we knew X would have to go on the integral sign. Time often shows up on the integral sign for the problems. And then we want to show that if there is no oil, we want the amount. Because again, that's basically what this is representing. This is representing an amount now. And we're showing that the amount that I can't spell, amount is equal to 0. Sarah?
So, would we be able to, like for this one, we would use the general rule? Or I forget which one's the simpler one? Or not at all?
This is the rewritten first FTC basically, in some ways. Because you're showing like this is the F of A, that's the A, and you're trying to show when the F of B is equal to 0. But we don't know when that B is, and that's why we have the X at the top. Is that what you're asking? Maybe.
No, but,
Oh, well, ask it again then, sorry.
well, I was thinking more like the common rule. But I guess that would have.
Oh, okay, you're talking about like the second fundamental theorem of calculus.
Yeah.
It is an integral defined function, but we're not taking the derivative of it, so that second FTC is not really applying in this case. But it would, if say I wanted to take the derivative of this, then yes, it would be the second FTC. Then you got a question?
Yeah, so I'm not sure it matters, but wouldn't C and T be bigger than LP? So we want if it doesn't matter.
I would still write this way because it doesn't matter if it's bigger, because you want to kind of think like, well, one, like we don't know which one is bigger. Like it could be between this interval, like from 5 to X, at some point it could be leaking faster. At some point you could be cleaning up faster. We don't know which it is. These are functions, they are changing.
Yeah, okay.
So we want to kind of leave in that format of LP minus CFT. All right, last slide. So again, I do want to give you time to start the homework just so you can ask questions on it as you get started. Also very common on the AP exam, I definitely know I have it on my assessments, where it is instead of setting up the problem, you kind of go in reverse. So it will give you some expression and you have to interpret what that expression means in the context. Let's talk about what we want to make sure we include when we explain our answer. Not looking for a paragraph. I am just looking for like a nice, short, clean sentence. But there are some things you have to be careful about, and I saw this a lot when I was grading AP exams this summer. There are certain things that AP exam just kind of looks for. And whenever you're explaining one of these things, you always have to include, state clearly what that symbol represents. So is it an amount? Is it a rate? State that clearly. Always include units of everything. So whatever you're talking about, just make sure you're clear about what the units of measurement would be. And then if you're talking about time, make sure you're clear on your units of time. So like, is it from a certain starting point to a certain ending point, or is it just at a certain point? And also just want to make sure you use the units on the time as well. So instead of saying like t is equal to 4, say 4 a.m. or something in the context of that problem. So go ahead and try those two. And then after a little bit, I'm going to put my answers up on the screen and kind of talk about like what at a minimum your answer should include. And then I'll kind of open it up in case you wanted to share your kind of response to see how much credit it would receive. This is where we're going to wrap up today. And then tomorrow I have like another problem that actually has like numbers in it, so we can actually have stuff to calculate and things like that. But this will at least get us started in this topic. And again, if you're stuck at trying to find a way to explain it, like just go back to your units. So like if you know what LFT is, and if you're integrating LFT, like think about what those units would be, and use that to kind of help you form your answer. So if I'm looking at this first one, LFT is representing gallons per hour. We're looking at the integral of L of t, so it's just gonna give you something in gallons, so I know I would be talking about amount. So how I would form my answer, and I'll tell you kind of where you would earn points from and what you have to include. This integral represents the amount of oil in gallons that leaks into the lake between 5 a.m. and 8 a.m. How this will be graded on the AP exam and things that the AP reader will be looking for, things that I will be looking for in your answer. Clearly have to state that we're talking about the amount of oil. Clearly need to state what that amount of oil will be measured in. Again, referring to this is the amount that has been leaking, so again, we're clear about what it's referencing. And then the time, this is what's happening between 5 a.m. and 8 a.m. Some common mistakes I see that you would make sure you don't do. I'm trying to think back to the summer, some ones I saw. Some people say something like between t equals 5 and t is equal to 8. Can't do that unless they just gave you the time as like t equals 5 and t equals 8. You wouldn't want to say something like over 3 hours or something generic like that. Yes, 5 a.m. to 8 a.m. is 3 hours, but it's not clear of like which hours you're talking about. And you wouldn't want to say something like just like at 8 a.m. So this is one that doesn't have the initial condition in front of it. You would want to make sure you don't say that. So Marcus, what's your question?
By 8 a.m., like having find the initial condition, that's the mark off.
Say it one more time.
Say like oil leaks into lake by 8 a.m.
You would lose points if you just said by 8 a.m. because you have to be clear with this is starting at 5 a.m. and ending at 8 a.m. Because if you just said by 8 a.m., that would technically be the one that would have like 4,000 plus the interval from 5 to 8. Where this one just has a clear start and ending, so it wouldn't need to state that. Taylor, you had your hand up. No, same question. So yeah, so just make sure when you're doing the intervals, that's usually where I saw the points students lost in the AP exam is you have to be clear with your time. And then looking at number 9, this one is the function L of 7 minus C of 7. While both L and C are functions given to you in the problem, they are represented in terms of gallons per hour. So my answer for this one is that represents the rate of change of oil in the lake at 7 a.m. Things you would definitely want to make sure your answer includes the units, which I should include, in gallons per hour. So don't be like me and include that. And so things you would want to make sure you include, this is referring to a rate of change. I would also need to make sure I included the units, which I skipped over the first time I wrote that. And then this is the rate of change at 7 a.m. There are ways to get around without saying clearly the rate or the phrase rate of change. So if you said like even like the net rate of oil or just mentioned rate in general, you typically gonna earn the point. Rate of change is probably the best way to explain that one though. Any questions on those two problems? All right, so what I want you working on, again, these word problems can range from like pretty straightforward ones to some pretty crazy ones that you can kind of encounter on the AP exam. On the homework, I am going to have you start, again, homework number 2, and this time we're going to do part B. On that homework, I try to choose 3 problems that were not overly difficult. I didn't want you to get bogged down in a super hard problem, but still like allow you to have the practice and kind of see how some problems were worked out. Part B, number 1, I give you one that has a function. Would use your calculator. And so this one, make sure you like evaluate. It's like once you set it up, punch it into your calculator and then actually find a number. The second one, I chose one that had a table. So again, you do have some numbers that you can estimate, or some like Riemann sums in there and things like that. And then the third question, I have one with a graph. Again, you can actually evaluate this one. Once you set it up, we know that the definite integral just represents an area. So you can kind of do that problem that way. We are going to do one more problem tomorrow because I do want to do a candidates test with these problems, especially for those of you who are new to me this semester. So like if you are starting it, I'd probably at least skip 1D for at least tomorrow. But I am going to go ahead and ask you, especially if you're at home, maybe put off that nap for just a little bit and start homework 2 part B. Just make sure you can kind of see how this gets started. And then we'll kind of finish it up tomorrow. Thursday, we're going to move into PVA problems, which I think are going to be easier compared to these types of problems. And then Friday is going to be your work day. So y'all can go ahead and get started on this homework. Again, I am here to answer questions if you have them.